The recent return of Super Heavy left the world in awe, realizing, oh, a launch pad can do something like that. That's when we truly started paying attention to SpaceX's Launchpad. But in the future, as countless similar and miraculous moments repeat themselves, SpaceX will undoubtedly need a more powerful launchpad. And that's exactly what Elon recently revealed about a new insane launchpad. Let's find out more in today's episode of Alpha Tech. And as always, thank you so much for joining us. All right, so as we know, SpaceX's current Starship launchpad has undergone unimaginable destruction before taking on its present appearance. Indeed, who would recognize this as the launchpad that has served Starship through its test flights? I still can't believe my eyes when comparing the past launchpad to its state after Starship's fifth launch. But that doesn't mean SpaceX's current launchpad, that's Launchpad A, is considered stable, as refurbishment still takes a significant amount of time and effort for SpaceX. And this is not the ultimate goal of Elon for a rapid rocket turnaround. And because of this, the new engineering project being constructed nearby has completely abandoned the old launchpad design and replaced it with a new one. Not only is it new, but it's also capable of withstanding far greater power than the combined thrust of 33 Raptor 2s, as Elon said in an announcement on X. The new launchpad is already designed for the 10,000 tons of thrust version, which is almost exactly 3 times more powerful than the Saturn V moon rocket. Indeed, it's clear that SpaceX is progressing steadily in the development of Starship rockets. There's no reason for them to stop now, and currently SpaceX teams and Elon's are accelerating the research and development of new Starship versions. Latest version being built is V2, which stands at 124 meters, 3 meters taller than the original version, meaning that the total thrust of the Super Heavy booster must also be improved to 8,240 tons. However, even when Starship V2 exerts its full force on the launch pad, it still won't be the limit of what this new launch pad can endure. That's because SpaceX plans to develop Starship V3, which will stand at a towering 150 meters and generate a thrust of 10,000 tons, the highest of any rocket ever built. This could explain why the old system's no longer suitable and a new system's required that can handle every launch without causing damage to the ground infrastructure. This new launch pad is completely redesigned compared to the first pad, with significant improvements such as a flame diverter to match the extreme heat and pressure generated during liftoff. The trench system will channel heat away from the launch pad, preventing the wear and tear that was common in previous launches using water-cooled steel plates. The flame trench has proven to be highly effective in tests, helping to make the launch pad more durable for repeated high-power launches, a critical factor as SpaceX moves towards higher launch frequencies in the future. Additionally, many other upgrades are based on lessons learned from Pad A. Recent images from a flight show clear progress in the construction of the flame diverter, with most of the excavation work on the west side of the pad already finished. SpaceX has also begun expanding the excavation area around the launch pad, possibly to install more ground infrastructure. Most of the notable advancements is the debut of the Mobile Orbital Launch Mount System. Unlike the current fixed system, the new mobile OLM will allow for easier maintenance and quicker refurbs. This mobility enables fast repairs or replacements of critical components, ensuring that launch ops can continue with minimal downtime. The new launch pad has 2 main parts, the upper section, which has a circular cut, and the lower section, which is smaller and has a larger square cut. The circular section features a similar design to the launch pad ring on Pad A, integrating both the hold-down clamps and the Raptor quick disconnect system to initiate the outer engines. The key difference with the new launch pad lies in the base. Unlike the previous pad, which only had a large ring attached directly to the legs, the lower square section can act as a connecting adapter between the launch ring and the flame diverter. Observing the base, there is a significant gap between the base and the ground. This gap may be temporary to facilitate construction work. Therefore, this is the right time for SpaceX to consider building more powerful launch towers. As development progresses, both Starbase and other launch sites will need to expand. More towers will be required to support the increasing number of launches, with a goal of 25 flights in the coming years and potentially thousands in the more distant future. Catching missions will also increase as both Starship and Super Heavy will need multiple launch pads. This expansion will not be limited to just Starbase either. Florida will also need to grow, as one tower may not be enough to support the planned frequency of up to 44 Starship flights a year, with more expected in the future. SpaceX may need to take over or build new launch complexes to meet these demands. The future of stronger launch pads is fast approaching. Are you ready for it? Comment yes down there if you agree. All right, so while SpaceX has made some great strides in development, the company is facing environmental and legal challenges in the areas where they're seeking to increase their launch frequency. Elon may see Starship as the vessel carrying all of God's creatures, but environmentalists, they tell a different story. As Starship prototypes started launching from SpaceX's Boca Chica site, these advocates argued that the company has shown little regard for the wildlife that Elon claims he wants to protect. As a result, it seems that every action SpaceX takes is scrutinized and turned into a reason for fines. Prior to the fifth Starship flight, the EPA and the Texas Commission on Environmental Quality, that's TCEQ for short, announced that SpaceX had violated the Clean Water Act. Both agencies fined the company $150,000 in September. Then on October 9th, Save RGV filed a second lawsuit over wastewater issues, seeking an additional $56,000 in civil penalties for each day of the violation. In a post on the platform X, SpaceX described the lawsuit as unwarranted and frivolous. Even before that, since SpaceX installed its water deluge system, environmentalists have filed complaints with Texas state regulators. To this day, and likely the foreseeable future, discontent with SpaceX's water flood system in Texas will likely increase, especially as the company continues building new infrastructure, including launch towers and pads in the area. For upcoming Starship flights, as part of an agreement with the EPA and Texas regulators, SpaceX will be required to conduct wastewater tests after each launch and submit the results to the regulatory agencies. Disputes over water discharge have already caused several months of delays, but they could lead to bigger headaches. Currently, the only place SpaceX is actually allowed to test Starship is the Launchpad at Boca Chica. To get it flying, SpaceX hopes to double the number of orbital test launches they can perform from 5 to 25 a year, roughly one every 2 weeks. However, the legal troubles aim to halt plans to increase the number of launches until the FAA does a more comprehensive environmental review. It's been difficult for SpaceX as the FAA suddenly suspended the process to increase the number of launches to 25 per year at Boca Chica. The agency is now reviewing the environmental assessment necessary to permit more frequent launches. This means that, at least for now, the company's limited to 5 launches a year. It should be said that SpaceX deserves to be allowed more, as they've got a valid reason to rapidly develop Starship. The rocket plays a crucial role in the company's future plans. Before any potential trips to Mars, it's expected to launch a new generation of internet sats into orbit, allowing the company to significantly expand its Starlink network. NASA also paid around $4 billion to use the rocket as part of their mission to return astronauts to the moon. This is the hope of us space enthusiasts, recognizing all the potential that SpaceX brings to the table. However, reality often paints a much sadder picture, as SpaceX doesn't just face difficulties launching Starship in Texas, but also struggles with Falcon 9 launches. SpaceX is looking to increase launches from Vandenberg Space Force Base in Santa Barbara County from 36 to 50 launches a year and up to 100 next year, clearly to expand Starlink, but some California commissioners have opposed the move, going against consistent decisions of the Air Force. However, the reason for blocking these additional launches is acknowledged to be political, as Elon has been heavily involved in the political conversation lately. This is indeed one of the most ridiculous reasons ever, going against the right to free speech for U.S. citizens. As a result, SpaceX has not hesitated to accuse the California Coastal Commission of political discrimination against SpaceX. Even the governor of California stated clearly, "I'm with Elon." Okay, so for more than a decade, no one can deny that SpaceX has operated efficiently with the Falcon rocket line. But in reality, SpaceX never intended to be just a satellite launching company. Their involvement in the satellite sector, especially the Starlink project, primarily aims to fund a much bigger ambition, and that's Starship's program. Last year marked a turning point when SpaceX successfully conducted Starship's first flight, dispelling doubts about operating such a big rocket. But the real shock came this year during the fifth flight, where SpaceX successfully captured the Super Heavy booster mid-air with the Mechazilla arm, a feat that few thought would be possible in the early days. Even Elon Musk was amazed, saying, "Amazing that this happened recently," alongside an impressive video of this unforgettable moment. This success marked a major milestone towards the goal of full reusability, promising to save billions in future launch costs. Right now, SpaceX is preparing for their sixth Starship flight, continuing its space conquest journey. And recently, on October 24th, SpaceX swiftly put Booster 13 into static fire mode just 11 days after the last flight, not only demonstrating the agility of SpaceX teams, but also shows the ground infrastructure's readiness to withstand the immense pressure from the 33 Raptor engines, including the Launchpad, OLM, and even the Mechazilla. The static fire test process of Super Heavy Booster 13 was executed systematically. Thousands of gallons of water got pumped through thousands of tiny holes in the cooling steel plate before engine ignition. And 3 seconds later, all Raptor engines fired. And if observed closely, water pressure increased significantly to counter the tremendous exhaust gases. The exhaust from Booster 13's 33 engines burned for 6 seconds, allowing SpaceX to check the whole process before the flight and detect any potential issues, particularly with the engines that need addressing before flight testing. Although no results have been announced, based on sound and video from the test, there doesn't seem to be any major issues, and after this static fire test, another wet dress rehearsal might be happening prior to the official liftoff. Ship 31's begun having its heat shield reworked, similar to Ship 30, which took about 38 days to complete, so Ship 31 will stay in the high bay tiling station for the near future. With tests like these preparing for an imminent flight, Starship Flight 6 will likely launch soon. Elon, SpaceX's head, responded to a comment on X saying, "Flight 6 coming up soon. Given the current situation, we estimate that the launch will probably happen around mid-November, as a month should be plenty of time for the next launch." Previously, right after Starship's Flight 5, the FAA confirmed that proposed changes for Flight 6 remain within the scope for the already approved Flight 5, suggesting that SpaceX has specific adjustments planned for the upcoming flight. Although these changes have not been disclosed in detail, they're likely focused on enhancing operational processes and procedures rather than making major structural modifications. Booster 13 is expected to carry several internal upgrades not yet known to the public. These improvements might involve the engine system, frame structure, or control systems, all of which will need validation under real flight conditions. Testing these upgrades will provide critical data for Starship's further development. Regarding durability on re-entry, many experts think that significant advancements in this area will likely be addressed in Flight 8 when the V2 version is expected to include modified forward attachment points. This is one of the most important design changes, but will also need additional time for development and testing. Payload capability is also a key future objective for Starship, but may not get tested on Flight 6. SpaceX wants to be cautious about introducing new elements to testing, especially when it involves transporting actual payloads. So Flight 6 will focus on validating the effectiveness of the internal upgrades, refining operational procedures, and gathering more data on overall system performance. While this flight may not yield any significant breakthroughs, it still plays an important role in laying the groundwork for more substantial advancements in the future. Some may wonder which flight will attempt to capture Starship. If you're guessing it might be Flight 7, that's still uncertain. While Flight 7 could theoretically meet Elon's promise to catch Starship by next year, the components planned for Flight 7, such as Ship 32 and B-14, are based on the Starship V1 config. This means that they may not actually have the necessary changes for a complete Earth re-entry. Moreover, based on Elon's prior comments, SpaceX will conduct at least 3 successful splashdowns in water before attempting to return the upper stage to the launch site. In a talk from back in July, Elon said that since there's a possibility of debris hitting or damaging property or people, SpaceX would aim for at least 3 successful landings of the ship before attempting a return to the launch site, implying that SpaceX will likely attempt to catch Starship with Mechazilla, starting with Starship Flight 8. Alongside SpaceX's rapid progress in preparing for Starship Flight 6, the company is also advancing the development of its Raptor engine. October 23rd, SpaceX conducted a notable test of its Raptor engine, firing it 34 times consecutively, which may represent a limit for engine ignitions. Although we don't have specific footage of this, it's an essential detail we can't overlook. It's almost a testament to the skill and expertise in every area of production that SpaceX's leadership team pushes forward with each day. The company managed to fire its Raptor rocket engine an incredible 34 times in under 10 minutes. These 34 test runs allowed 5 consecutive starts and firings an hour later. This is the first test of its kind and is likely part of SpaceX's approach to push its rocket engines to their limits to understand any potential design flaws. Raptor reliability has been an initial concern for the Starship launch program, and through continuous flights, SpaceX seems to have resolved several types of design issues. These engines are among the most powerful in the world and are also more efficient than SpaceX's Merlin, which powers the Falcon rockets right now. While the goal of these tests won't be fully clear until SpaceX shares specific info, it's likely that these rapid-fire tests are part of SpaceX's efforts to stress test their engines. Testing for failure is an integral part of the company's development process as it assesses thousands of internal components within complex systems, like rocket engines, to identify potential weak points. These tests allow SpaceX to improve the safety and reliability by enabling the company to address potential anomalies early on before they could lead to accidents. Aside from this possible goal, SpaceX may also have other objectives in mind. The Starship program represents one of SpaceX's most ambitious endeavors, setting new standards in rocket development. At its core is a dual objective: achieving full reusability of the second-stage spacecraft and establishing an orbital refueling system. The orbital fuel depot is particularly crucial for NASA's Artemis program as it enables SpaceX's HLS, the Human Landing System, to refuel before its lunar descent, marking humanity's return to the moon since the Apollo days. The evolution of the Raptor engine showcases SpaceX's innovative approach to rocket propulsion. The latest iteration, Raptor 3, exemplifies the principle that sometimes less is more. By eliminating unnecessary joints and seals, SpaceX has created an engine that's not just lighter but also more reliable. The absence of a traditional heat shield, while making the engine appear deceptively simple externally, necessitated the development of sophisticated internal cooling channels, a testament to the complex engineering hidden beneath its surface. One of the most intriguing aspects being tested is the potential use of Raptor engines for attitude control in space. Unlike Crew Dragon, which relies on cold gas thrusters for precise maneuvers during ISS docking, Starship's exploring the possibility of using its main engines for similar precision control. This capability would be revolutionary, as it would eliminate the need for separate thruster systems and potentially enable more efficient maneuvering in space. The development of rapid engine firing capabilities serves multiple purposes. Beyond attitude control, these quick-fire abilities could revolutionize how rockets decelerate during descent. Instead of traditional long burns, multiple shorter firings could offer more precise control and potentially better fuel efficiency. This technology could prove crucial for interplanetary missions where precise maneuvering and fuel conservation is critical. Looking to the future, these technological advancements position Starship as more than just a lunar landing system. The combination of reusability, orbital refueling, and advanced engine control makes it a potential platform for various space ops, from Mars missions to deep space exploration. The ability to rapidly launch fuel tankers to maintain orbital depots could become the foundation for a true space transportation infrastructure. In the heart of Texas, SpaceX's new Starship factory at Starbase represents a revolutionary leap in aerospace manufacturing. Drawing inspiration from Tesla's gigafactories, this state-of-the-art facility is designed to transform rocket production from a slow individual process into a rapid assembly line operation where traditional aerospace manufacturers might spend months making a single rocket. SpaceX's new facility aims to produce multiple Starships at the same time, dramatically reducing both production time and costs. In the live stream of Starship's fifth launch, once again, we had the chance to witness new views inside SpaceX's massive factory. From here, part of the factory's operations have been revealed. In the early stages of Starship production, SpaceX relied on a temporary setup using large tents to manufacture prototypes. These tents were chosen for flexibility, allowing SpaceX to quickly establish a production line without needing to commit to a permanent facility. This temporary setup enabled the team to experiment freely with different designs and production processes, an important factor given that Starship was an entirely new type of spacecraft with no established blueprint. This flexibility proved to be a major advantage during the initial phases. Without a rigid infrastructure, SpaceX could rapidly adjust its manufacturing techniques based on immediate feedback from test flights and real-time assessments. If a particular design didn't do well, the team could modify or scrap it and try something else without facing major downtime or costly reconstruction. This approach enabled SpaceX to iterate quickly and learn from each version, which was critical in refining Starship's complex design. However, the tent system came with significant environmental challenges. Located at Starbase, Texas, the tents were exposed to dust, mud, and wildlife, creating an unclean and inefficient work environment. These open conditions made it difficult to maintain the high precision and cleanliness necessary for aerospace manufacturing. The constant exposure to dirt and debris complicated the production process and highlighted the need for a more controlled environment, leading Elon and SpaceX to plan for a dedicated, purpose-built Starship factory to streamline operations and improve production quality. That's when Starfactory was born. With a new design and new operating procedures, Starfactory is now in production of Starship V2. The manufacturing process for V2 at SpaceX's new Starfactory is centered around a unique production method that Elon calls linear adjacent flow. The linear adjacent flow method focuses on parallel assembly. Separate segments of the rocket, like the nose cone, body sections, and thrust segment, are built in parallel at individual stations and then combined at the final assembly stage. This approach enables faster production cycles and increases flexibility in the assembly process. In contrast to the traditional assembly lines pioneered by Henry Ford, which typically feature a single long line where each station completes a specific step of the process, SpaceX's adjacent flow structure allows each part to be developed separately and brought together only when segments are fully completed. This method, also used in Tesla's unboxed manufacturing process, aims to avoid the inefficiencies of back-and-forth handling of parts and assemblies, eliminating the need to dismantle or reattach sections, which can slow down production and add to material wear and tear. Each station within the Starfactory is set to complete highly specialized tasks, from cutting and welding stainless steel for the rocket's body sections to shaping the nose cone and assembling your fuel tanks. Each task has a dedicated area with specific tools, materials, and personnel skilled in that particular function. The stations work in sync to ensure that no step in the process delays the others, achieving a steady production flow without unnecessary downtime. By organizing manufacturing in this way, SpaceX has created a streamlined environment where each phase of production proceeds smoothly, allowing for rapid construction of V2. This manufacturing setup not only supports higher production rates, but also enables quality control and testing at each step, making it ideal for a product as complex as a reusable orbital vehicle. Starship V2 production line at Starfactory operates through a meticulously organized step-by-step process, starting with the raw materials and then ending with nearly completed rocket segments ready for final assembly. The process starts at the end of the building, which is far from the road, where large rolls of stainless steel are cut and welded into rings that form the main body of the Starship. These rings are then stacked and joined to create sections of the rocket's hull, with each segment composed of 3 to 5 rings. Precision is key here, as these welded sections must withstand the extreme pressures and temperatures of space travel. Simultaneously, the nose cone and fuel tank domes are created through a technique called hydroforming, which uses high-pressure water to shape stainless steel into the desired forms. These intricate sections require advanced shaping to achieve the aerodynamic precision necessary for atmospheric reentry. The nose cone is equipped with heat shield tiles and flaps, crucial elements that protect the spacecraft and control its descent path. The fuel tanks, shaped by the same hydroforming process, form the top and bottom of the propellant tanks essential for the rocket's fuel storage and burn during flight. Once individual components are ready, they are assembled into larger sections, with each stage of assembly handled at dedicated stations within the factory. Specialized stations for mounting heat shields, plumbing fuel tanks, and installing thruster assemblies ensure that each part of the rocket is completed and tested before getting joined with the others. This segmented approach allows quality checks at every phase, reducing the likelihood of issues in later stages and supporting a faster and more efficient production flow. The final assembly takes place in Mega Bay, a towering structure adjacent to the factory that serves as the last stop for Starship segments. Here, your nose cone, body, and thrust sections are stacked to form the full Starship structure. In Mega Bay, Raptor engines are installed and final electrical and plumbing connections are made to prepare the vehicle for testing and then eventually launch. This large area allows SpaceX to complete and stack each Starship while efficiently managing production for the next unit, enabling rapid turnover as SpaceX moves closer to its goal of routine, large-scale rocket production. With a clear and efficient process free from any major obstacles, SpaceX is well on its way to achieving the ambitious goals it has long envisioned. SpaceX has set an ambitious production target for Starship in aligning with its long-term mission of making space travel routine and enabling human settlement on Mars. In the short term, the company aims to make 100 Starships every year at its Starbase facility in Texas, turning out roughly 1 rocket every 3 days. This level of production will support an increase in satellite launches, lunar missions, and other projects as SpaceX ramps up Starship's operational capabilities. However, the long-term version is even more ambitious, producing 1,000 Starships every year. This scale of production is central to SpaceX's Mars colonization plans, which imagines a fleet of Starships capable of transporting both cargo and large numbers of people. To meet these ambitious targets, SpaceX also plans to expand its manufacturing capacity with a second Starship factory near Cape Canaveral, Florida. This new facility would double production and allow SpaceX to leverage the nearby Starship Launchpad at Kennedy Space Center for quicker and more efficient testing and deployment. Together, these two facilities are designed to support rapid scaling, ultimately allowing SpaceX to meet demand for high-frequency space missions and lay the groundwork for human life beyond Earth. The coming months will be a period of powerful growth for SpaceX. With the successful completion of Starship's fifth launch, SpaceX is set to accelerate its launch pace. It seems that in just 2 more flights, we may witness an impressive version of Starship V2. It's impossible not to mention this monster in the last part of today's video. The development of Starship V2 marks a significant leap forward in SpaceX's mission to create a fully reusable, high-capacity space vehicle. Built on the lessons learned from previous Starship iterations, the V2 versions incorporates refined designs, enhanced features that address issues identified in earlier test flights. Through rigorous testing and flight data analysis, SpaceX has transitioned from the experimental, sometimes inconsistent builds of the first Starships to a more standardized, reliable version capable of meeting ambitious mission objectives. One of the most noticeable improvements in Starship V2 is the re-engineered nose cone. This design now incorporates diamond-shaped flaps with a pointed trailing edge, an upgrade that helps direct atmospheric shock waves away from the vehicle during re-entry. By positioning these flaps on the nose and adjusting their shape, SpaceX has minimized the accumulation of heat and pressure, which proved problematic in earlier designs. The nose cone modifications, along with a lower profile hinge mechanism, help improve aerodynamic performance and protect critical sections of the spacecraft during its descent through Earth's atmosphere. The aero flaps have also been redesigned with significant improvements. Early test flights revealed weaknesses in the hinge mechanisms, causing excessive wear and, in some cases, structural failure during re-entry. In response, the flaps on Starship V2 are not only higher and thinner, but their shape and positioning now optimize the vehicle's ability to control descent, enhancing stability and resilience during atmospheric re-entry. The primary goal of Starship V2 is to achieve rapid reusability, allowing the spacecraft to be flown multiple times with minimal refurbishment. This evolution is central to SpaceX's larger version of making space travel more accessible and affordable. With the upgraded design, Starship V2 is envisioned not just to serve as a reusable orbital vehicle, but also as a reliable transport system to get us to the Moon, Mars, and beyond. SpaceX's ultimate objective with Starship V2 is to lay the groundwork for sustainable, routine journeys to other planets, advancing humanity towards a multi-planetary future. While we can dream of hundreds of thrilling scenarios for Starship once it's fully operational, it's important to acknowledge that SpaceX still has a long road ahead. Successfully catching the Super Heavy booster marks a major milestone, but it's only one small piece of the bigger Starship puzzle. So, what are the next steps? Moving toward the future, one key step SpaceX is expected to take is the in-space engine relight for Starship. For those who might not recall, during Starship's third test launch, SpaceX's top team had planned to perform an engine relight in space. However, that attempt got ultimately skipped, possibly due to the second stage's instability during re-entry. Since then, across the fourth and fifth test flights, SpaceX has not revisited this maneuver, continuing instead to guide Starship's second stage along a short trajectory toward the Indian Ocean. But SpaceX's ultimate goal isn't limited to just a single, simple trajectory, right? Many intricate in-space operations will require Starship's ability to relight its engines. The capability to relight in space will enable Starship to conduct complex orbital maneuvers and dock with other spacecraft critical for missions involving rendezvous or in-flight course corrections. Without this capability, Starship's scope for diverse orbital operations could be quite limited. Additionally, relighting engines mid-flight offers flexibility to manage unexpected situations or off-nominal events during launch and ascent. Should an issue arise early in the flight, the vehicle could attempt to abort and return to Earth via engine relighting. Moreover, the ability to relight Starship's engines is essential for in-space transport and refueling operations. The vehicle may need to perform multiple burns to transfer payloads to various orbits or reach escape velocity for deep space missions. Reliable engine relights are indispensable for achieving these complex maneuvers. Given all this, the next flights, Starship Flight 6 and 7, are ideal opportunities to make a fresh attempt at this critical maneuver. SpaceX seems to have this goal in sight, as demonstrated with their recent Raptor tests, where 34 of them got relit in a span of 10 minutes at their Texas facility. Once this effort succeeds, Starship will enable SpaceX to start orbital flights with Starship, potentially paving way for Starlink launches as early as the first half of next year. These will involve bigger Starlink satellites, designed to fit within Starship's higher payload capacity, and will provide direct mobile internet capability. For Flight 6, SpaceX has prepped Starship's upper stage, known as Ship 31, and recently transported the Super Heavy booster, that's Booster 13, to the launch site for static fire tests. In terms of hardware and regulatory readiness, a test flight in November seems entirely possible. SpaceX's next major milestone will be successfully landing the Starship upper stage. To date, every test re-entry of Starship has ended in burning up or explosion. Only once SpaceX masters catching this super heavy booster midair will they begin serious effort to land Starship's second stage back on solid ground. And here, important to note, this means just landing Starship on land, not yet catching it. Unlike Super Heavy, which could either be caught or redirected to the ocean, Starship has just one option: successful landing. As a result, catching Starship will be a bit riskier than catching Super Heavy, as any error could lead to big-time hazards. Experts suggest that SpaceX may initially aim to land Starship on solid ground at an alternate location to refine the complex operation. While we saw impressive accuracy from Ship 30 in Flight 5, which landed precisely in the ocean as shown on nearby cameras, this isn't enough for SpaceX. They can't compromise public safety for their rocket program. To prepare for the eventual catching process, SpaceX might first conduct landings on isolated landings, with rumors circulating that they scouted the Johnson Atoll in the Pacific earlier this year. Such remote locations would offer safer options for returning Starship to solid ground. However, Starship currently lacks landing legs, which would be essential for lunar or Martian landings. So the question remains, will SpaceX fast-track landing leg development now, or will they instead work through regulatory hurdles to catch Starship in South Texas? Following a successful catch of both Starship stages, the next crucial step for SpaceX is going to be in-orbit refueling, a mission-critical goal they have to accomplish by fall next year to enable lunar missions. Though this milestone is eagerly anticipated, much groundwork needs to be laid before any orbit refueling test can happen. For the fuel transfer demonstration, SpaceX will first launch a target Starship into low Earth orbit. A chaser Starship then follows to rendezvous with this target in space. When the two crafts meet, the chaser vehicle transfers a substantial amount of cryogenic propellant to the target. Finally, the two vehicles will separate, with each executing its own orbital burn. To pull off this demonstration, SpaceX needs to complete several key preparations. They'll need to construct a second launch tower in South Texas for the Chaser's launch, as well as develop and test quick disconnect docking mechanisms, navigation sensors, and hot gas thrusters. Despite pushing ahead with these preparations, SpaceX has yet to announce a specific date for this test, though insiders indicate it may happen next year, meaning we'll likely have to wait another year to witness this milestone. Regardless of the outcome, SpaceX will likely conduct further rounds of testing to refine the process. And after that, what's next for SpaceX? How about reusing the booster for the first time? Some may say it's unlikely, given SpaceX took over 15 months to reuse the Falcon 9 booster after its first landing in December 2015, finally achieving this in March of 2017. Not to mention, Super Heavy is a bit bigger and more complex than Falcon 9. Furthermore, the B-12 booster, recovered from a previous flight, is now on display at the Rocket Garden. Now, that may be true, but we're talking about a new booster, one likely to be spotted in the coming months and quite possibly flown for a second time. Engineers are already gathering immensely valuable data on the vehicle's performance and hardware endurance. Following this month's booster launch, Elon commented on social media, "Good chance that Starship achieves full-stack reusability in 2025, critical breakthrough needed to make life multiplanetary." This suggests that SpaceX aims to relaunch both the booster and the upper stage early next year, though the timeline seems optimistic, especially for Starship's upper stage. We can hope that SpaceX will soon achieve success for their spacecraft after extensive testing. At this stage, Starship is now considered to be operating stably, and it should soon be ready to prepare for larger missions, such as a lunar landing under NASA's contract. To accomplish this, SpaceX must conduct an extended-duration Starship flight. The spacecraft needs to be capable of maintaining independent operations for up to 100 days while awaiting the arrival of the Orion crew vehicle. This will require complex systems to keep liquid propellants at extremely low temperatures and to ensure all systems are stable over extended periods. Development progress on the project has been delayed by about 3 years from the initial target set for 2021, reflecting challenges that engineers have to solve. However, SpaceX continues to make notable advancements in Starship's development and testing. Automation capability is also essential for Starship, as the spacecraft has to be able to autonomously adjust its orbit, maintain life support systems, and perform complex maneuvers without direct crew intervention. This demands sophisticated control algorithms and highly reliable computer systems. NASA and SpaceX are working closely together to finalize the lunar variant of Starship. Lessons from test flights will be applied to improve the spacecraft's performance and reliability. This collaboration represents a new model in space exploration, combining the expertise of a government space agency with the flexibility and innovation of the private sector. And by mid-2027, Starship will be expected to make an uncrewed landing on the Moon, followed by a return to orbit. This test will be critical for Starship to prove itself before carrying a crew to the lunar surface. One of the most significant challenges in Starship's lunar missions involves landing terrain requirements. Unlike previous lunar landers, Starship is a bit bigger and requires extremely precise landing site selection. The moon's surface at the landing site must have a slope of no more than 1.5 degrees from an ideal plane to ensure the spacecraft remains balanced during landing. During this test flight, Starship will not only demonstrate landing capability, but also test its cargo transfer system. A critical part of the mission is verifying the elevator system, which will be used to transport astronauts from the spacecraft to the lunar surface in future missions. The mission's critical phase will be the moon takeoff. This unprecedented challenge arises from Starship's use of an entirely different fuel system compared to Apollo landers. While Apollo relied on hypergolic propellants, which can be stored at normal temperatures, Aerozine 50 and nitrogen tetroxide, Starship uses methane and liquid oxygen, requiring extremely low storage temperatures. Takeoff is further complicated by the fact that Starship must accomplish this without any supportive infrastructure on the moon's surface, no launch tower, fueling systems, or auxiliary equipment. This will be the ultimate test to determine whether Starship is truly suitable as a lunar landing vehicle. The results of this test flight will be pivotal. NASA and SpaceX will thoroughly analyze every aspect of the mission, from system performance to operational reliability. If significant issues are identified, they may conduct additional test flights before proceeding with Artemis 3, the mission to put astronauts on the moon. If all goes well, NASA may fulfill its original Artemis program goal of landing 2 astronauts on the moon in 2028. This target is 2 years behind NASA's current goal of 2026, yet remains an ambitious task for both SpaceX and NASA. However, if obstacles arise, such as a failed catch tower or issues with in-space refueling, the program could get delayed even further. As time has passed since Starship's Flight 5 mission, discussions in the space community have not quieted down. In fact, they've only gotten more lively. Recently, SpaceX released a breathtaking onboard video, offering a spectacular and panoramic view of the final moments of Starship before it touched down on the water. This footage has captured the special attention of us space enthusiasts. However, the flight also revealed some unexpected challenges that we hadn't anticipated before. The video starts with Starship in its distinctive belly flop position, a key innovation in the vehicle's re-entry strategy. In this configuration, Starship is oriented horizontally, using its broadside to maximize drag and slow its descent through the atmosphere. This approach allows for more efficient deceleration compared to traditional propulsive braking methods, conserving valuable fuel for long-distance missions. Moments after engine ignition, we witness one of the most critical and technically challenging aspects of Starship's landing sequence, the flip maneuver. The spacecraft swiftly transitions from its horizontal orientation to the vertical position, crucial for controlled landing. This rapid and precise movement requires complex coordination between Starship's aerodynamic control surfaces, the flaps, and the powerful Raptor engines. When comparing the recent landing footage of Starship to the SN-10 high-altitude test, we see significant progress in the control and landing precision. The SN-10 flight conducted in early 2021 featured a similar belly flop maneuver performed by Starship's upper stage. But during the SN-10 test, the landing sequence was less refined. While the flip maneuver was effective, SN-10 saw a rougher landing, ultimately resulting in damage and an explosion shortly after touchdown. In contrast, the recent test showed improvements. The belly flop was followed by a much smoother flip, leading to a more controlled landing. The landing burn was executed precisely at the designated point where the company had placed a camera on a nearby buoy. This allowed for a clear view of the intense interaction between Starship's engine exhaust and the ocean's surface as it approached splashdown. This creates not only just a really cool visually dramatic effect, but also shows unique challenges for the landing process. The turbulence and steam generated can potentially affect visibility and interfere with sensors and control systems. A water landing like this has given us valuable experience for future ocean landings, and it could even be applied in potential emergencies that Starship faces down the road. The video ends with a final explosion that, was not ideal, but despite that, it demonstrates that Starship successfully executed its landing burn, completed the flip maneuver, and achieved a controlled descent with definite improved accuracy. SpaceX shared the video with great pride, stating, "Starship flight maneuver and landing burn on its 5th flight test. Vehicle improvements ensured flaps were protected from high heating, resulting in a controlled entry and high-accuracy splashdown at the targeted area in the Indian Ocean." This also signals a promise of further improvements in the future. Elon's even confidently stated, "Hopefully early next year we'll catch the ship too." That seems like a reasonable time frame for SpaceX to refine its systems even more. But on which flight will SpaceX attempt to catch Starship? First, SpaceX might conduct Flight 6 later on this year, following the same protocol as Flight 5, meaning that the ship still lands in the ocean. Any changes could involve the landing site possibly shifting to the Pacific in preparation for a catching attempt, potentially on Flight 7. The second possibility is to try catching the ship on Flight 6. However, this might delay the flight till next year, which would result in no additional flights for this year. Each option presents challenges that might not meet our expectations. Should SpaceX prioritize rapid launches or focus on perfecting the catch? Let us know your thoughts in the comments down there below. No matter which path they choose, we're approaching a major milestone where both stages of Starship can be successfully caught. Pretty cool, right? This will be the first time a rocket is fully recovered and reused. Achieving this will serve as a critical foundation for SpaceX as they move forward with plans on payload launches, developing refueling systems, producing Starship's HLS, and prepping for Artemis and then Mars missions. Looking ahead, the competitive landscape of the aerospace industry is definitely changing, and SpaceX is leading the way. Earlier, SpaceX also released another new video, this time focusing on Super Heavy, which was just as cool. This video provides a clear view of the vast area surrounding the launch site, though the main focus remains on Super Heavy systems. In this view, we can clearly see the grid fins working hard to guide the booster, a key factor in steering Booster 12 precisely into position for catching. However, at first glance, the grid fins appear to be functioning steadily. Now, if you slow down the footage in a few seconds, you'll see that the grid fins did encounter some issues. At T plus 2 minutes and 40 seconds during the separation process, a hot staging technique was used. This method allows the engines on the spacecraft to ignite while it's still attached to the booster. This technique, yes, is familiar to many of us. It appeared to affect one of the grid fins. Cam angles from both the booster side and the spacecraft showed that the flame from the engines during hot staging seemed to impact the grid fin. And this raises concerns, as any damage to the grid fins could compromise flight safety and performance. Thankfully, this issue did not affect B-12's overall performance. The grid fins continued to function well, guiding the booster to a successful landing and marking an awesomely historic achievement. However, SpaceX should consider upgrading the separation system to prevent any adverse effects on the grid fins and other components. Given that SpaceX is striving for full reusability, they would likely prefer not to have to replace grid fins after every flight. The moment the engine ignites for landing is also a truly remarkable image. It's marked by a flame. As the burn progresses, the flame, initially large, gradually decreases in size as the middle ring of the engine cycles on and off. From the bottom-up perspective, the center engines of Booster 12 can be seen operating efficiently. These gimbal engines not only provide the necessary thrust to slow down the booster, but also continuously adjust their direction, ensuring B-12 follows an exact path. SpaceX remarked, "The final phase of Super Heavy's landing burden used the 3 center Raptor engines to precisely steer into catch position." Now, what stood out to me, however, was the intensity of the burn on each side of the booster, particularly near the ship's quick disconnect or QD area. While the fire wasn't big, it burned intensely compared to other areas. From different camera angles, it becomes clear that this side burned more fiercely. A comparison between the live stream and post-flight images shows slight damages to the chine on the ship's QD side, likely caused by fire during landing. Fortunately, damage was minimal and easy to fix. The onboard footage also shows an impressive slow-mo view of the moment Super Heavy connects with the chopsticks. This allows us to appreciate just how awesome this accomplishment was. The timing was impeccable. As the chopsticks close, they proactively engage the booster, touching the landing rail and then lowering into place. While this stage has caused concern before the flight, the flawless execution has now given confidence for future missions. Elon even expressed his optimism, stating, "Good chance Starship achieves full stack reusability in 2025, which is the critical breakthrough needed to make life multiplanetary." And so, Super Heavy's B-12 challenging mission came to a successful end. With every piece of data SpaceX releases, we get deeper insights into the mechanics of Mechazilla's incredible catch of Super Heavy. It is hard to overstate the significance of this, one of the most impressive aerospace feats of the decade so far. Even Elon said, "It's an honor to work with the incredible SpaceX team." Following the mission, B-12 was transported back to the production site for analysis. B-12 was lifted by the chopstick system from the OLM and placed onto the booster transport stand. This process only took more than 2 hours. Then, B-12 arrived at the Mega Bay facility for a detailed inspection. Engineers will analyze any issues from the flight, including damages to the chine grid fins and engines. This data will be important for future upgrades to prototypes. It's uncertain whether B-12 will get refurbed or flown again, although many hope for a reflight. The hardware for the next mission's already been chosen, and the new V-12 model's been built, making another flight for B-12 unlikely. Instead, B-12 may get displayed in the Rocket Garden, similar to S-20 or the Starhopper, given the significant contributions to the program. During the recent move, SpaceX also provided a closer look at the Raptor engines. Elon had previously mentioned some warping in the nozzles, which raised concerns. However, recent images show the engines are in way better condition than expected. It appears that one of the three inner engines and one engine from the outer ring exhibits some warping, but the majority of it looks fine. Additionally, it's worth mentioning that this is the only V2 engine of the Starship, and in the future, the rocket will use a different engine version, the V3. Now, of course, the newer engine version is an upgrade over the previous one, so it'll combine all the benefits with the new upgrades, making the Raptor as reliable as possible. We see that the Raptor 3 engine has a sleek black coating, which could be a new material designed to prevent warping from the heat. Based on all this, it seems SpaceX is ready to meet all standards for full reusability. At present, SpaceX will need to more thoroughly evaluate any issues, but this early process towards reusability is very promising. The results quite encouraging, and we can look forward to SpaceX's next steps. As the excitement from the success of Starship Flight 5 still resonates within the space community, we can't overlook the contributions of the leaders who made this dream a reality. Now, besides Elon Musk, the well-known figure closely associated with SpaceX, there's another equally important person, and that's Gwynne Shotwell, the most powerful woman in the country. Now, if someone were to ask me who leads SpaceX, I wouldn't deny Elon's role, but my first answer would be Gwynne, the key figure behind turning SpaceX's vision into reality. So, as president and COO of SpaceX, what did Shotwell declare after the first successful catch of the 33-engine booster by the tower? Unlike Elon, Gwynne Shotwell is known for her quieter achievements. However, the first ever mid-air catch of Super Heavy's booster may have left her so thrilled and speechless that she simply posted on X, "I don't know what to say." I wish Shotwell would express herself more. But she's always been someone who lets her actions do the talking. In fact, if you search for news articles about Gwynne Shotwell's currently doing for SpaceX, particularly with the Starship program, you're not going to find much. It's only for those of us who have followed SpaceX for quite a while who recognize her immense contributions. When it comes to the Starship program, Shotwell has played a major role since the early days. When people think of Starship success, they often focus on the technical achievements, but financial management's just as crucial. Back in 2012, Elon estimated that the Starship program would cost between $5 and $10 billion to develop, and just this year, SpaceX plans to invest around $2 billion into the rocket system. Now, it's worth noting, maybe forgetting, that SpaceX put up a loss of $968 million in 2021 and $559 million in 2022. The company only hit a small profit of $55 million in the first quarter last year. So, without a doubt, Starship has been a bit of a strain financially for the company. Although Elon's the richest person in the world, he can't foot the bill of all the Starship on his own. So, what has Shotwell, as president and SpaceX's top salesperson, done to ensure that the company survives and grows over the last 20 years? The company's revenue primarily comes from rocket launch services through commercial contracts with national organizations like NASA, private companies, and individuals. Shotwell has been instrumental in leading efforts to build the Falcon launch manifest, securing over 50 launches that made $5 billion in revenue. This includes commercial connections to the International Space Station to provide resupply services, where SpaceX delivers cargo and supplies to the astronauts. Additionally, she's been a staunch supporter for SpaceX's cost-cutting approach through reusables. Under her leadership, SpaceX achieved major milestones, including the first successful landing of the first stage of an orbital rocket and the reuse of flown rockets, which have become a hallmark in the company's operational efficiency. To max out revenue sources, Gwynne devised a smart and efficient business strategy known as residual capability. While SpaceX's core technology is in rocketry, she had the foresight to expand to other areas like the Starlink satellite network and Dragon spacecraft, utilizing SpaceX's rockets to launch them. Although neither of these directly serves the Mars colonization goal, they've created sustainable business models here on Earth and helped build the technologies that are going to be needed for those future Mars missions. After establishing a solid financial foundation for Starship, Gwynne Shotwell continued to support Starship by ensuring SpaceX maintains strong diplomatic relations with the government. This is evident in her role in securing launch permits for each Starship test flight. Shotwell always seems to be at the forefront of these tense permit applications. She's the one who presents all aspects of Starship's development to prove and convince congressional officials during those public hearings. Given that regulations and environmental concerns are a bit of a challenge for Starship's development, getting a launch permit is not easy. This often gives Shotwell headaches, as she stated before House officials.
We can build a rocket and get it prepared for launch faster than we can get the bureaucracy to approve us to launch.
In fact, I couldn't believe that Starship Flight 5 could launch earlier than the original FAA announcement, which was the end of next month, November. But just within a month of the September flight delay announcement, Shotwell likely handled all the complexities, enabling SpaceX to launch Starship in early October. Now, despite the political tensions between Elon and the Democratic government officials, Shotwell continued to do her job effectively, addressing the previous baseless accusations made by environmental agencies against SpaceX.
But for sure, we want to continue to enhance regulatory efficiency so that regulation does not hold back technology and innovation. This is not an issue for our competitors overseas. It is an issue in the United States. Less so in Texas.
She was referring to the sanctions imposed on SpaceX by U.S. federal agencies. The FAA's first move was on August 12th when it unexpectedly announced a delay in hearings regarding the environmental review of SpaceX's plan to increase Starship launches from the South Texas facility. The action seemed to be more specific when CNBC put out a controversial article regarding SpaceX's environmental issues. Another issue Shotwell had to address at the end of September was the defense of FAA Administrator Mike Whitaker. During the hearing on September 24th, Whitaker explained the Starship faced more delays because SpaceX had filed a launch application without disclosing that it had violated Texas law. The EPA stated that the company had violated the Clean Water Act at the Starbase Launchpad, resulting in a $150,000 fine. SpaceX also faced a proposed fine of over $630,000 from the FAA for violating launch licenses during Falcon 9 and Falcon Heavy launches last year. Whitaker said this fine was unrelated to Flight 5, but the agency claimed the company's unauthorized use of a new control room and fuel farm during those launches raised safety concerns. Now, of course, fines of hundreds of thousands of dollars, that's not a big deal for SpaceX. Instead, it felt more like a heavy blow as the company was accelerating progress towards its goal. Shotwell also candidly expressed her personal opinion.
You will probably enhance the regulatory environment, and there's just a caution that you really want to make sure that regulation doesn't impede progress.
After all, her efforts, honesty, and determination paid off as the progress of Starship's Flight 5 moved faster than the FAA's initial decision. It needs to be said that not just anyone, even a highly talented man, could have accomplished this. A promise, of course, is indispensable. Shotwell delivered all her thoughts in an inspiring way. I'm certain her words in that speech naturally serve as motivation for many space enthusiasts like us.
At Starbase, we are paving the way for humanity to be truly spacefaring and a multiplanetary species. I know that might sound crazy. It sounded crazy to me when I joined the company over 20 years ago, but I really am committed to this.
Not only did the FAA have to respect this woman, but even NASA had to acknowledge that SpaceX was being led very well by Gwynne Shotwell. Of course, everything wasn't easy in its early days. As Elon shared, there was a massive effort to block SpaceX from providing astronaut transport for NASA. That's where Gwynne Shotwell's exceptional negotiating comes in. Can't help but mention her top-notch sales skills in negotiating contracts with tycoons in the space industry. Interestingly, when Shotwell was a new member of SpaceX, she quickly became the director of business development and was immediately tasked with an incredible mission: selling rockets that didn't yet exist, and of course had never flown before. She started meeting with U.S. government agencies and SAT companies to start convincing them to book launches on their still unflown Falcon 1 rockets. Somehow, the young unicorn SpaceX at the time secured its first contracts with agencies like DARPA, a Malaysian satellite startup, and above all, a major national organization, NASA, not to mention dozens of Falcon 1 flights for other customers. All this happened before it ever reached orbit. She was also the bridge for the long-lasting close cooperation between SpaceX and NASA. Honestly, during his time as senator, Bill Nelson's relationship with SpaceX was not the best. His opposition was mainly directed at Elon's eccentric behavior and erratic conduct as the leader of a company capable of making a global impact. Nelson was chosen to lead NASA in 2021, and to this day, his cautious attitude towards Elon remains. This is due to Musk's decision-making processes, which have been heavily scrutinized in the past, particularly regarding some of his other companies like Twitter and Tesla. For instance, in October 2022, when Elon carried out the tumultuous takeover of Twitter, Nelson feared it would affect SpaceX's operations, and the first person he thought of was not Elon, but SpaceX's president and COO Gwynne Shotwell. A few months after he bought Twitter, though before he renamed it to X, in late 2022, Nelson recounted to NBC News his relief when discussing the acquisition with the SpaceX president. "Tell me that the distraction that Elon might have taken on Twitter is not going to affect SpaceX," Nelson recounted to NBC News that he asked Gwynne Shotwell. "I assure you it's not," Shotwell responded, according to Nelson. "You have nothing to worry about." He emphasized that the encounter ended up friendly because he knows Shotwell, not Musk, is running SpaceX. "I hugged her with a smile on my face because I know she's running that thing. She's running SpaceX," Nelson said. Asked whether he has any concerns about SpaceX, Nelson said, "No, I don't." California might have just become a place where no business should remain, especially SpaceX. Now, that may sound like an exaggeration, but in reality, certain government parts here have gotten so politicized that they disregard the interests of the entire country. Perhaps California still sees itself as the economic center of the U.S. with various industries and feels it doesn't need SpaceX. So, what did California's government just do with SpaceX and Elon? What's the true intention behind this government action? Last week was a mixed week of success and failure for Elon. On Sunday, he celebrated the successful test flight of SpaceX's Starship rocket, but days later, California's Coastal Commission, the CCC, rejected plans to increase rocket launches from California's coast. This led to a lawsuit by Elon in response to the CCC's opposition, in which he also is asking the court to bar the CCC from regulating the launch program. Falcon 9's rocket launch program has been enthusiastically supported by Space Force. In September, the agency proposed that SpaceX be allowed to increase its annual rocket launches at the Vandenberg Space Force Base, a military base on the coast near Santa Barbara in California, from 36 to 50. SpaceX also does commercial launches from this base to send their Starlink satellites into orbit. Of course, both of which assured that their respective organizations would closely monitor the impacts of rocket launches that might have on the nearby wildlife. The CCC's official duties include overseeing plans and regulating the use of land and water in the coastal zone. However, by their own admission, the decision to reject Falcon 9 program appears to be less about wildlife concerns and more about Musk's personal political opinions. Committee members voted 6-4 against increasing the number of launches. Citing a reason for their objection, Commission Chair Carol Hart stated, "We're dealing with a company the head of which has aggressively injected himself into the presidential race." Commissioner Gretchen Newsom added, "Elon Musk is hopping about the country, spewing and tweeting political falsehoods and attacking FEMA while claiming his desire to help hurricane victims with free Starlink access." Commissioner Mike Wilson piled on the anti-Musk rhetoric, saying of SpaceX, "The company's owned by the richest person in the world with direct control of what could be the most expansive communication system on the planet. Just last week, that person was talking about political retribution." Wilson's choice to use the term political retribution seems like an odd choice of words. After all, is the CCC not engaging in political retribution by Elon by rejecting his plans based on his political beliefs? Prior to the CCC's decision, there was some debate as to whether the commission should have any say in the Falcon 9 plans at all. Vandenberg Space Force Base contracts with SpaceX because the rocket launches provide useful information that aid the military. Now, considering the relationship between SpaceX and the military, this should classify Falcon 9's program as federal and thus not subject to the CCC regulatory discretion, as Space Force officials are arguing. The only obligation the military has to the CCC in this instance is to agree to mitigate the effects on wildlife, which it's already agreed to do. The Commission has repeatedly argued against the military, asserting that because Falcon 9 also serves Elon's own ends, it's a private activity and falls under their authority. Now, it'd be one thing if the CCC had any substantial and legitimate concerns about the coast's environment that haven't already been addressed by the Air Force and Space Force, but their decision seems to be rooted in disdain for Elon's comments on social media, which are completely irrelevant to Falcon 9. This has indeed not only affected SpaceX, but also the economy of the state of California. It's undeniable that California is one of the economic hubs of the United States. When we look at it, we might think that just leaving Tesla or X, especially SpaceX, won't really change the market there. However, in reality, SpaceX has brought a lot more to California than we realize. As one of the most prominent private space companies in the world, SpaceX has maintained their primary operations inside California, bringing numerous benefits to the state. The company's headquarters and main manufacturing facilities are located in Hawthorne, California, and the LA metropolitan area. This strategic placement has created a substantial economic impact on the region. SpaceX employs thousands of workers in high-skilled positions, ranging from aerospace engineering to advanced manufacturing, while fostering a culture of innovation and entrepreneurship that extends far beyond the space sector, contributing to California's reputation as a hub for technological innovation and skilled labor. Cali's economy benefits directly from SpaceX's presence through job creation, tax revenue, and the stimulation of local businesses. The company's operations have led to the growth of a robust supply chain inside the state. Many suppliers and contractors based in California support SpaceX's ambitious projects. SpaceX's ops in California have also led to increased collaborations with educational institutions and research facilities in the state. These partners have helped promote STEM education and advanced space research, ensuring that California stays at the forefront of technological advancement and maintains a pipeline of skilled workers for the future. So, we can see that the absence of SpaceX in California would make the region feel quite bleak, and the value that SpaceX brings is something that other businesses might not be able to replicate. Looking further, it seems that the California government is trying to punish Elon by attacking his company. They dislike Musk because of his outspoken nature and his ability to reveal uncomfortable truths. This has led to the perception that Elon is not particularly supported by government officials. However, Musk's decision to sue the CCC, along with plans for SpaceX to potentially move out of California, comes with many reasons behind it. Elon's volatile relationship with California has been quite storied. The tech tycoon launched SpaceX back in 2002 in Hawthorne, a city in the LA metropolitan area, and enjoyed a number of tax breaks and incentives over the years, including more than $3.2 billion in direct and indirect California subsidies and favorable tweaks to market mechanisms since '09, according to statistics from Governor Gavin Newsom's office. However symbolic, the move is likely to reignite the perennial discussion about San Francisco's doom loop, the idea that the city by the bay is trapped in an unstoppable decline. With its 800,000 square foot headquarters located in downtown San Francisco, X was one of the last remaining companies with substantial facilities in the area. Since 2019, the 20 largest tech firms have slashed the amount of office space rented in downtown San Francisco by half. Just last month, Twitter began seeking subleasees for its offices. San Francisco's downtown has been attempting to reverse urban blight for about 15 years. X, formerly known as Twitter, previously benefited from a tax break enacted in 2011 meant to attract companies to the mid-market area of San Fran, which has long struggled economically. The law was sunsetted in 2019, and the X headquarters departure could represent yet another blow to the area, where 46% of offices and 40% of retail spaces are vacant. Other companies that have left or downsized their operations in San Francisco since 2021 include Meta, Salesforce, Snap, Lyft, Block, Airbnb, and PayPal. Many employees and customers of Musk-owned companies will inevitably remain in California, making these moves more symbolic in effect than practical, experts say. Musk previously relocated the headquarters of Tesla, his electric car company, from California to Texas in response to the Golden State's coronavirus measures, which he called fascist as he clashed with regulators about keeping his facilities open in spite of the pandemic. Today, though, multiple Tesla factories are still in California, including one of its largest manufacturing sites, the Gigafactory in Fremont. As long as these companies still have an economic presence in California, the state will still have an effect on them, said Eric Talley, professor of corporate law at Columbia Law School. If you want to completely seal yourself off from the state, you would need to not only move your headquarters, but also stop making sales and stop manufacturing in California, and I doubt that's going to happen. How exactly the changes play out could be more pronounced for SpaceX and X than it could be for other tech firms, as Elon has been quite adamant about employees returning to in-person work. After acquiring X back in 2022, Musk ordered almost all his employees to return to the office full-time, demanding that they be extremely hardcore. SpaceX likewise has an in-office mandate for employees. Musk's announcement and targeting of Newsom on X sparked a back and forth between the executive and the California governor, who tweeted, "You bent the knee," implying Musk had pledged his loyalty to Trump. Musk then responded, "You never get off your knees." That's it for today's episode.